Hello everyone, this is 𝐂𝐨𝐴 and today we are back with another video in which we are discussing capacity estimations. I feel like back of the envelope estimations that we call that anytime you give the interviews or actually you are designing a system, that let's say you are designing such system, you have to figure out the basic needs of like what is kind of storage you require, what kind of support you are providing for the response time of the APIs. So to all that capacity planning, what kind of instances you require, what kind of memory the instance should have, what kind of CPU the instance should have. So all these kind of estimations you have to do so that the cost is major factor, because you have to figure out the solution you are choosing because in the end money matters, right? In the end money matters. Either it's your startup or it's your big enterprise, whatever infrastructure you are spending on, what is the amount you are spending on, basically what is your IMR. So what is your total cost on the infrastructure, that matters. So the system you are designing, definitely you will have to figure out that volume of data you have to store. You have to figure out what are the instances you will use, okay, what kind of machines you will use. So let's discuss and deep dive into how you can actually do it during the interviews as well as your actual system design while you are doing it as part of your job. So when we say back of envelope estimations, there are few things to consider. One is that what is the amount of storage we require, okay. So what kind of one question is that what kind of storage you require. So that kind is different, but once you have figured out that, yeah, let's say I am using MySQL, okay, I'm using MySQL. So if I'm saying I'm using MySQL, then what is the total amount of storage I will require? According to it, I can figure out, okay, so this is the instance type I require to host my database and all. So first thing is what is the total storage? Okay, this is the first thing, that what is the total storage required for my application. Then another thing is there are some parameters that are related to this storage, so that we will discuss. But before that, let's discuss on what kind of parameters will the total storage depend on. Okay, so first thing is type of data. So to let's take one example to understanding better. Like we few days back I published a video on how can you design systems like WhatsApp. So in WhatsApp we did basic capacity planning and the estimations of storage which is required to support or to store our data. So in WhatsApp example, what we did was, so the total number of, definitely you will also have to specify what is the number of users. Okay, so first, and definitely you can discuss all these numbers with your interviewer, that yeah, I'm assuming that these are the number of users for the application which I am designing. Okay, because the number of users will define that what is the storage actually I require on my system. Okay, so let's say for our WhatsApp application, we are taking example of WhatsApp. So for our WhatsApp application, the total number of monthly users were 2.24 billion. Okay, and the total number of messages which are sent across the system were 100 billion messages per day. So in that video, we took a basic assumption that in case of these messages, the messages can be of three types, right? Either it is text, either it is images, or it can be videos. So if we consider the ratio of these messages, this is, let's say, 70x, this is 20x, and this is finally your 10x. So if we talk about 100 billion messages per day, so what we mean by that is, if we say 70% of those messages are text messages, then total of 70 billion messages are sent as text, 20 billion of messages are sent as images, and 10 billion of messages are sent as videos. So if we consider around total storage which we required for this much of a requirement of messages to be stored, so what will be that? For that, you will have to identify what is the average number of storage required for storing single message. So let's say for one message, for one text message, you require, let's say, 128 bytes, okay, and for one image you need 1 KB, and for video you need 10 KB. So these are your average numbers. Definitely your image can be bigger, your video can be bigger, or your messages can be small and large, but we are taking just an average number, that this is the storage which I require for a single message. Now if I talk about total storage which I require per day, total storage per day, so it will be basically 70 billion into 128 bytes plus 20 billion into 1 KB plus 10 billion into 10 KB. Okay, so this is the total storage which we require, and as I remember from the previous video, it was around 118 TB per day. So if you see, this is a huge storage requirement that we are looking at. Definitely in case of one factor would be at till what time you want to store this data. In case of WhatsApp, we don't want to keep this data like all the time on the server. We will delete this data as soon as the messages are delivered to the customers, or like two users are interacting with each other. Once the message is delivered to the recipient, once the user is delivered to the once the message is delivered to the recipient, it will be deleted from the server. So definitely you will have to get the requirements straight out from the interviewer that yeah, this is the storage which I am thinking of, because if you see this number, right, this number is kind of huge. This number is kind of huge. So you will have to figure out that what kind, like till what time you need this storage. So this is per day, so according to the number which you specify, because let's take in another example of tiny URL, right? So in tiny URL we mentioned that let's say we need the storage to be we need the URL to be expired after 10 years. So we will have to calculate the storage for 10 years basically in beforehand, so to think about that this is the storage you will require in the end, and once the URLs get expiring after the 10 years, you will keep on deleting them, so your storage gets freed up. So these are the kind of things you will have to keep in mind to figure out that this is the storage which I require. Now apart from this, there are some other parameters that you have to consider. One is around the replication. So we do discuss a factor that we generally replicate the data so that our solution or our we are able to provide a redundancy or durability for our storage. So for that we replicate the data on multiple instances. Let's say this is I'm using just an S3, okay? So S3 can do it automatically at its end, or you can configure that your data is replicated across the regions. So these kind of things you can do, and if you're doing that, you are using extra storage. So let's say this is your 118 TB and you are replicating at 3 places. So that way the total storage will not be 118 TB, it will be 118 into 3. So this is the total storage you are looking at. So these kind of things you will have to keep in mind, that this is the total storage which I require if I want to replicate the data as well. Another thing related to is, if I say 118 TB, is there any compression algorithm being applied on this? So if I'm looking at this number, is there any compression algorithm applied to it? So in that case, maybe these messages or these images are compressed to, let's say 128 bytes, and this is, let's say, 1 KB. So these things also you will have to consider while calculating the storage. How good is my compression algorithm? This is just in case of images and video. If let's say there is no compression applied for a particular use case, then definitely you can't consider it. But just to get the gist of the use case, you will have to figure out that yeah, these are the things which can be considered, these are the factors which matters for my use case, and what would be the final storage that is required for my use case. Now another use case could be let's say in case of videos, okay? In case of videos, am I storing this video in multiple formats? So we took an example in case of Netflix discussion, that whenever a video is uploaded in Netflix, it is converted to multiple formats and multiple resolutions, and they can be displayed to user as per the use case, or like as per the bandwidth available at the user, or per the device which is being used by the user. So let's say one is let's talk in terms of resolution as of now. So one is 1080 pixel, let's say, okay? One is 360 pixel, one is 480. So these are the kind of resolutions I'm talking about. Apart from that, then there can be multiple formats, that MP4 is available, M4V is available, MP3 is available. This is not a video format, but yeah, so these are the things you will have to consider, because this will lead to a replication of data. So the number you have come up with does not hold true. It will be multiplied with what is the storage required if I convert the video into 1080, what is the storage required if I convert the video into 4K. So these are the things you will have to consider if you are calculating the total storage. Now apart from this storage, there can be other use cases as well. So for storage only, this is just the basic storage, right? Now there can be other things which you might consider. In interviews it generally depends, because I will not suggest that you spend more time on this capacity estimations. I will suggest that you just spend 2 to 3 minutes or max 5 minutes on capacity estimations if interviewer is more interested into it, because you should spend more time. It's just the interview, right? So you should just get the understanding straight that this is the kind of estimation I am looking at, and then move forward. Okay, don't spend much time if it's an interview. If it is like then definitely if it's a real-time system, then you will have to think more, and you can definitely give it more time. But in case of interview, this should be good enough. Now what I was saying that there can be other parameters as well. What other parameters? Parameters as in one is caching solution. Okay, so let's say you are also caching this data to make it available faster. Another is, let's say you are using CDN as well to store this data. So these kind of things you will also consider, that how much extra storage I require, or let's say I store some metadata in some of my DD. Okay, so let's take that example of images and video only. Okay, so in this case of in this example, what I am doing, I am storing a metadata. That this is my S3 URL where this particular video is present, and it is actually stored in S3. So this is the extra storage you are using to store the metadata. The metadata can be anything, right? Metadata can be anything. This is the example of images and video. So similarly, you might need some extra data as well, right? Let's say your profile picture. So this is not related to messages. This is profile picture. Then let's say what is the user information, or data related to user metadata. Let's say when was this user last seen, or in case of WhatsApp architecture, we discussed that we will be using Redis to store WebSocket connection. So you will have to figure out all kind of storage depending on the use case. So just identify, as I mentioned, in case of system design requirement, it's system design interview or system designing in general, it is important that you identify the requirements. The requirement should be cleared. You can spend at least 5 to 10 minutes in this section, so that your requirements are fine grained and what you actually want to design, so as you don't need so many assumptions. Definitely if you are taking the assumptions, definitely call it out. If you are taking any assumption in the interview or during the system design of real life systems, call out the assumptions you are taking and discuss with the interviewer or your program manager or your whatever tech people you have. Discuss with them that this is the assumption I am taking, and if this assumption hold true, because discussions lead to a better way. Discussions lead to, if you are missing something in a way, then definitely it will help to figure out how can you do it. Now another thing during the capacity estimation would be back of the envelope estimation or capacity estimation would be what kind of infrastructure you want to use. We mentioned that this is the kind of machine I want to use for developing my application. So if I say that what is the infrastructure required? So for calculating the infrastructure, for not calculating, for figuring out what is the infrastructure used. Okay, so let's take example of AWS, because I heavily worked on it. So let's take example of AWS. So if I say I'm using AWS, let's say I'm using EC2 machines. Okay, there are definitely multiple compute platforms used. Let's say Lambda or ECS. Okay, so let's say we are using EC2 machine. Now if I'm saying I'm using EC2 machine for my use case, let's say we are considering an application X. Okay, this application, let's say this is message service. So if I'm saying this message service, so what kind of infrastructure should be used to launch this service, or what kind of infrastructure, what kind of machine will be used? So let's say I'm using M4.4x large. Now you should have some kind of justification on to figure out why do you see that this instance type is the instance which will meet your requirements. Another one is what is the total number of instances. So let's say I need 10 instances of this type, or I have combination of, let's say, 4 M4.large with 10 instances and M4.4x large with 10 instances. So how can you actually figure out? You will have to figure out by calculating what is the total TPS, or what is the maximum processing can be done that can be done by a single machine. If you are able to figure out that, if you are able to figure out somehow that, then you can easily say that this is the instance should be good enough. Now if we use cloud, right? If you are using cloud, it's pretty straightforward, or like it's pretty easy. You don't have to actually order the hardware. You don't have to actually order the hardware. So as you launch the system, you can start from scratch. As you launch the system, you can start from scratch. Let's say I'm using just T2 micro, or I'm using M4.large. Okay, basically anytime you are launching the system, you will figure out, you will first launch the system into, let's say, beta environment or your dev environment, development environment. Then you will be moving this application to production. So in this beta environment or development environment, you can do some basic load testing. And this basic load testing will help you to figure out what is the traffic I am looking at in production, how it will help. You just have to run your traffic on a single instance, and once you run that single instance, when you run the traffic on single instance, you will be able to figure out what's the backing point for my system. If I'm using M4.large instance, I can figure out what is the TPS that can be easily served by system. Let's say I am using M4.large, what is the total number of WebSocket connections it can maintain. So without like thinking too much, or like if we do a simple POC, if we do a simple POC, proof of concept, if we do simple implementation and see how many how many TPS or how many users a single system can handle, or if I'm doing any kind of processing, let's say I'm converting the videos from 1080 to compression to 360. So by doing this, what is the processing time taken by my system? So these kind of things will be able to figure it out. You will be able to figure out key, this is the instance which is meeting my need, and if I specifically use this particular instance, then let's say this can serve my 10 TPS total. It can process 10 requests in parallel. If I am giving 11th request to this particular system, then it will be in the queue. Okay, so these things how it will help is you will be able to figure out like a correct number that can be used, because that will be helpful, right? That will be helpful to actually save the cost, because as we discussed in the earlier at the start of video, that because cost matters. Save not most, we are saving cost, we are not saving most. So we will have to figure out what is the instance we have to. We already discussed how you can calculate the storage. Now another part is, there are some other discussions around like that will not be around the capacity, but around the TPS or like the latency we are looking at. Okay, so again, you can also define it with basic assumptions in the start, that looking at my system, this should be the TPS that can be served, or like this is the, let's say my request will be solved in 1 second. Again, while you are doing the load testing, while you are doing this load testing, you can do it that time as well. So as you figure out, okay, these are the number of requests, this is the request that is being served by this M4.large. Okay, so if I'm saying this, I also have to figure out that if I'm saying that 10 requests are being served within a second, now what is the time taken? What is my response time, or what is the basic latency if I'm looking at a particular API? So they will be definitely defined at a API level. Your latency, or like your processing, or any of the operations you are doing, they will be defined at a API level or at a operation level. Okay, so once you figure out that, you can do it via your basic load testing, and then you can see for optimizations if they're required. ठीक है कि मेरे को और performant बनाना है, तो either you can go for a better instance type. Let's say instead of using M4.large, I'm using M4.4x large. Or you will have to look into bottlenecks into your code, or the way you designed your system, or can you use some other layer on top of it. So these things you will have to consider to do it. So yeah, these are the things which you will have to keep in mind when you are actually designing the system. So I hope you enjoyed the content and you got the basic gist of how you can actually do it during the interviews or during your real life system design problem solving. So stay tuned, we will be meeting again with a new video. Tab tak ke liye stay safe, tata, bye bye.